name is Defne, and this is my digital logic design project. The name of my project is DJ Station, and I wanted to make something like a DJ board, which with as much creativity and freedom as possible. There are 3 different loop audios and 2 one-shots. The loop audios are as following. This is a drum sound. It's the classic guitar sound. It's the bass guitar sound. This is the air horn one-shot, and this is the scratch one-shot. The one-shots are assigned to buttons, while the loops are assigned to switches. How I did this is that these were originally WAV files, and I converted them to code files using Python, since that's the only audio file type that Basis 3 can read. And then I put those files into 5 separate block memory generator IPs. The width of those IPs are 16-bit, because that's like the chosen bit size of my project, and their depth was the sample size of each audio, which is different for each of them. And how the loops and one-shots work is that loops start from 0 and count until the address counter starts from 0 and counts until that certain sample size, and then reverse back to 0 and then counts again. The one-shots, when they hit that sample size, they just stop, they don't count again. I've got 4 different effects, and the name of the effects can be seen in this part of the 7-segment display, and their intensity can be seen in this part of the 7-segment display. The first effect is the echo effect, the distortion effect, the slowing the pitch effect, and the reverse effect. So let's start with the echo effect. The echo effect can be seen the best with the one-shot. Let's just make the intensity of it something like 12, and it echoes like so. How I did this is that I made a separate single port RAM inside the code, and this RAM stored the last 1.48 seconds of the current audio. That number was chosen because of the RAM of the Basis 3. The storage of it was an issue throughout the project. That's why I used 5 audios while 8 was intended, and I have chosen the sampling rate I choose because of, again, the storage. So it stores 1.48 seconds of the last audio and adds to the mixed echo. It adds to the mixed echo, and then it adds the new echo to the echo, which has the old echo and adds to the end. The intensity switches determine how loud the echo is, and the echo also decays over time. I did the decaying by just halving the audio, by just shifting it to right. And the intensity switches are multiplied by the echo, so that means the higher the switches are, the louder the echo becomes, and since it always decays at the same rate, the decay just lasts longer, so there are more echoes overall. The next effect is the distortion effect. How I did this one is that I took the audio and I shifted it right and to left, killing the last bits, and how much of those bits are killed depends on the intensity switches. I'll just show it to you. I'll make it a strong number, like let's do 14. It'll be very loud and it can be heard very clearly. It's the distortion of the drum. So yeah, that's how I did it. And the next effect is slowing the pitch effect. So for this one, I made it so that when the switch is on, the cycle holds its current state instead of going to the next cycle. Like all the counters for the audios and stuff just stop where they are, they preserve their current state and do not go to the next one. That causes the audio to slow down. And how long they hold their state instead of going to the next one is determined by the intensity switches again. So this is intensity 8, only, yeah, this were so. So the next effect is the reverse effect. The intensity switches don't do anything for this effect, because since it's just, reverse. And how I did this one is that usually for loops and one-shots, address counter starts from 0 to the last bit, but this time it starts from the last bit and counts down to 0. And once it hits 0 for the loops, it reverts back to the largest bit, and then 0 again. For one-shots, when it hits the 0, it just stops. Also, I used potentiometer to control the master volume of the whole audio, and the volume level can be shown with the LEDs here as I turn the intensity switch, up and down. For example, for the, it controls the master volume. Also, I used anti-resto PMOD to convert the digital sounds to analog sounds and to be able to connect them to headphones for us to hear it. So this is my whole project. Thank you for watching.